Hey everyone, welcome back to the NumPy for AI series. Before you scroll away, let me tell you this. If part 1 was just the warm up, part 2 is where real AI magic begins. Indexing, slicing, reshaping. These might sound simple, but they are literally the backbone of machine learning, deep learning, data science, and almost everything you'll do in Python from now onward. So, if you want to handle data sets, train models, manipulate images, or build anything meaningful in AI, this 10-minute session is going to boost your skills instantly. Alright, let's jump straight into the coding. Let's begin with the basics. I am importing NumPy and creating a simple one dimensional array. This array will be our playground today. We'll slice it, index it, and modify it step by step so you can clearly understand how NumPy works behind the scenes. Simple indexing. Indexing in NumPy works exactly like Python lists. 0 means first element, two means the third element, and negative indexing lets us move from the end. Very useful when working with long data sets. Slicing basics. Slicing is one of the most powerful features in NumPy. The syntax is start colon end, but remember the end index is not included. This is super important. If you're coming from another programming language, this might feel different, but in Python and NumPy, it becomes second nature. Step slicing plus reverse. Now let's add a third argument called the step. With this, you can pick every alternate value. And one of the coolest tricks, using negative step reverses the entire array. This is very handy when preparing sequences or cleaning data. Create a two-dimensional array. Alright, now things start getting interesting. Let's move from one-dimensional to two-dimensional arrays or matrices. You'll use matrices a lot in machine learning, especially during linear algebra operations, matrix multiplication, and neural network transformations. Indexing in two-dimensional arrays. In two-dimensional arrays, NumPy uses row first and column second. So matrix 0, 1 means row 1, column 2. If you want an entire row, just mention the row number. If you want an entire column, use colon for all rows and the column index. Two-dimensional slicing, sub-matrix. This line extracts a submatrix, basically a smaller block taken from the bigger matrix. If you're doing image processing, this is exactly how you crop images or extract pixel regions. Reshape. Reshaping is one of the most essential parts of machine learning. Your model expects data in a specific shape. Maybe 2 rows, 3 columns, maybe 1 row with 6 features. Maybe a 28 cross 28 image. Reshape handles all of that. Flatten. Flattening does the opposite. It converts a matrix back to a one-dimensional array. Neural networks often expect flattening before feeding data into dense layers. Transpose. Transpose is simply flipping rows and columns. This is super important during matrix multiplication and while working with linear algebra formulas used in deep learning. Mathematical operations. Operations in NumPy are extremely fast and extremely simple. Addition is element wise. Multiplication is also element wise. You can square an entire array in one line. And statistical functions like mean, maximum, sum. They are incredibly useful when analyzing data sets or checking values inside your tensors. And that brings us to the end of NumPy. Now you officially know how to index, slice, reshape, flatten, transpose, and perform vectorized operations, all of which are essential for building AI and ML projects. In next, we'll move into more advanced topics like broadcasting and vectorized computations, the stuff that actually makes NumPy, and give an introduction to Pandas as Python. If this video helped you, hit the like button, subscribe to Corporate Connection, and drop your doubts in the comments. I'll reply to every single one. Thank you so much for watching, and I'll see you in the next part of AI series.